This is problem number 4 on the sample test problems for test number 1. A particular model of car costs $24,000 to purchase new. After 2 years, the value of the car will have dropped to $16,000. A, assuming that the value of the car decreases in a linear way, find a formula for its value 2 years after it was purchased new. Okay, so the formula I'm going to work off of is y equals mx plus b. But maybe instead of these letters, we'll use different ones. Instead of y, we can talk about the value of the car, v. M will be slope. It feels like the input here is time, t. So instead of x, we'll put t for time, and then plus b. Okay, so then we've got some good data here. The car initially cost $24,000. So in terms of like making some t, v points, I know that initially, when time is 0, the cost of the car is $24,000. So that's 1 point. And I know that 2 years later, the cost is now $16,000. So that's my second point. So given 2 points, we have a whole process to try to find the equation of the line. Certainly we need the slope. Used to be change in y over change in x. Now it's change in v over change in t. So we subtract 24,000 minus 16,000. And we divide by 0 minus 2. So we get 8,000 divided by negative 2, which is negative 4,000. The negative is good because the value of the car is dropping as time passes. And once we know the negative 4,000, I think we should take this gift, which is the y-intercept. The y-intercept is 24,000. So that means that ultimately the equation is v equals m, which we found was negative 4,000, times t, plus the b, plus 24,000. It doesn't, I guess it doesn't ask for the interpretation, but the interpretation of this negative 4,000 is that the car is losing value at $4,000 per year. Part B, according to your formula, when will the car's value drop to half of its original value? So original value is 24,000, half is 12,000. And now I'm just going to copy the rest of that equation right there. Negative 4,000 t plus 24,000. And we'll solve this thing for t. So subtract 24,000 from both sides. Divide by negative 4,000. And we get t equals 3 years. Part C, what will the car's value be after twice the time you found in B has passed? So in B we found 3 years. So if we wait twice as long, we're waiting 6 years. So we're going to go with this equation up here circled or boxed in purple. We're going to plug in t equals 6 years. Negative 4,000 times 6 plus 24,000. So that's negative 24,000 plus 24,000 equals 0. So it took 3 years for the value to get cut in half. After another 3 years, it doesn't get cut in half again. It completely has lost all value. E. Assume instead that the value of the car decreases in an exponential way. Find a formula for its value t years after it was purchased new. Same idea as before. We've got these 2 points right up here. And we're trying to find an exponential function that hits those 2 things. So you have different choices. I'm going to go back to our y equals a times b to the t. But then maybe instead of y, we'll change that to a v. Again, we have a gift. It's circled in red. That 24,000 is the value of a. The y-intercept is the value of a. So we get v equals 24,000 times some unknown b to the t. Now we'll plug in the other data point. The other data point was When t was 2, the value was 16,000. So when t is 2, the value is 16,000. T is 2, value is 16,000. And then we have a little work to do to find b. So we divide both sides by 24,000 and reduce, I think we get 2/3. It's b squared. So that means that b is the square root of 2/3. Technically it's a plus or minus, but bases are always positive. So let's get an estimate here from the calculator. So we're doing the square root of 2/3. And I'm going to round that to just 0.8, but I'd like to keep the non-rounded number, or at least as much accuracy as the calculator can. So I'm going to store, hit that button there, and I'm going to call it b, because that's what we've been calling it here. So b for me is this green right above the apps button. Second, nope, alpha to get the green. You can see it turns into an A for alpha, and then we hit the letter b. So anytime I ask it for the value of b, it's going to know 0.8 and all those other digits that I don't feel like writing. So it's about 0.8, which means my final equation from here is v equals 24,000 times 0.8 to the t. E, according to your formula from D, when will the car's value drop to half of its original value? Okay, so half of the value is 12,000. So we're using that equation there. We're going to plug 12,000 for the new value, copy everything else, and to the unknown t, we'll find t, which will be how long it takes for the value to get cut in half. So we'll divide both sides by 12,000 and get a half equals 0.8 to the t. The variable is in the exponent, so this is a good time to use logs. So we're going to do log of half equals log of 0.8 to the t. If you want to use the common log instead of natural log, that's perfectly fine. ln of a half is some number we'll get from the calculator. T comes down in the front, so it's t ln of 0.8. And then finally, to solve for t, divide both sides by ln of 0.8. So we get ln of a half divided by ln of 0.8. So I'm going to type that into the calculator in its rounded form. So if I just type in ln of a half, I'll clear ln of 1/2 divided by ln of 0.8. And we get that it's about 3.1 years is how long it takes to get cut in half. But this 0.8 was rounded, and we went ahead and stored that 0.8 with all the digits as b. So how about we just do the same thing, second entry, we'll delete 0.8, and instead right there we're going to put b. So we do alpha and then the b right there. And this will give me the most accurate answer the calculator can find. And you can see it's quite a bit different, 3.1 years versus 3.4 years. So I'm going to write that answer. So it's about 3.4 years is how long it takes. And then it says, according to your formula, what will the car's value be after twice the time you found an E has passed? So we're using this formula again, but we're going to plug in twice the time we just found. So V equals 24,000 times 0.8 to the T. How much is T? Twice the time we just found. Twice 3.4, 6.8. Okay, again, you could just type that in the calculator, but I'd like to avoid any kind of rounding error. So how about we take this number, which was our 3.4, and we go ahead and double it right now, times 2. That's really what it should be instead of this 6.8. And then I think you could either store that number or we can just use the answer feature here on the calculator. So I want 24,000 times 0.8, which is B, raised to that number. So 24,000 times, I'm not going to type 0.8, I'm going to do B, raised to the, but I'm not going to type 6.8, I'm going to do second answer, which refers to the previous line. So we do second answer. And 6,000 is the answer. And you saw on the calculator it was exactly 6,000. So it took about 3.4 years to cut the value of the car in half. And after another 3.4 years, it gets cut in half again, from 24,000 to 12,000, and then from 12,000 to 6,000. And this is a feature of exponential functions. However long it takes for the value of something to get cut in half, it's going to keep getting cut in half for that same period of time.